samples
In this
as we
session,
want.
we take a look
Okay.
at forecasting.
Now, in this example,
so what kind of
we take three
forecasting
samples.
we're talking about here?
For
Let me
each
throw out some
sample,
examples. For
we
example, we want to know
calculate
the weather
the sample mean.
in the future.
What is a
For
sample
example,
mean?
tomorrow,
Sample mean
2 days later,
basically
1
is
week
the
later.
average
Okay, we want to
of
know
the sample.
probably
For
the
example, in
demand
sample
level
one,
of iPad.
the average of 95,
next
94, 93, 95,
We probably
95
want to
is
know the stock price of
94.
IBM tomorrow.
In sample
Those
2,
things
the average
are
of
the
the
things we don't
five,
know. But
five
we
measures,
would like to know.
the average
So
is
we
96.
use forecasting
Sample
methods
3,
or
the average is
forecasting techniques
94.8.
we're going to cover in this
If
chapter
we repeat
to predict the future value of
the
those
aforementioned
variables.
process
For
many
example,
times.
weather, demand,
And what do we do is
and
we
the
plot
stock
them
price.
above
So there are
this
some underlying assumptions.
x-axis.
Here's a good analogy that
we plot the values
we're driving
of
a
X
car,
bar.
a vehicle. We can.
It will
There's no
look
front window, so we
exactly
cannot see
like
anything
like
in front
this,
of us.
the highlighted area.
So what do we do when we drive?
Why so?
When we
This
cannot
is,
see anything
this
in front
comes
of us,
from
which is
a
the future.
statistical
We never know
theory.
what we're going to have
Statistics
in the future.
theory, that
Okay.
is the
So,
central limited theorem,
The best thing we can do
tells
is
us
to
that
look back.
if we take a lot
If
of those
We
samples,
look back,
and
and
if we
the road
plot
is
the
straight
X-bar, it
on
looks
our
like
back.
this.
We
Now,
say, you know what?
What I mean,
It's gonna be
plot here
straight
is the so-called
again.
dot plot in statistics.
going forward.
So,
If we see a
if,
curve on the back,
you need
then
to
we will say
review
that,
that
the curve
part.
continues.
Please
Okay,
go
that's the
back
analogy
to the statistics
for our
textbook
forecasting.
and
So,
search for
when
the
we do
keyword
forecasting, we never know what's gonna happen in
dot
the future.
plot.
But we assume
Now, the next thing comes from
that
statistics is
the
a
trend
central
in the
limit theorem.
past will continue in the future.
We're not going to
Is this
repeat
assumption always correct?
the central
not.
limited theorem,
But
theorem
that's the
here.
best
What do we
thing we
need
can
to
do.
do is just
So
to take
that's
it as
the
a
underlying
given,
assumption of forecasting.
and
Now, because we know that forecasting is something we look into the future,
know that
and we never know the future,
it
we
looks
make
like this
assumption
shape
that
here.
the past trend
So
will
this is a
continue
normal
into the future.
distribution.
So we know that forecasting
for
can
any
never
given
ever be perfectly accurate.
any
And
given
further,
sample. Remember, we have
The
three
longer the
samples,
term
right,
we look
in our
forward,
example,
the less accurate
we take one of it out.
our
Now,
forecasting
if the
will
X bar, which
be.
is
Now,
the sample
we can
mean,
roughly divide the
fall in
forecasting
between
approach
2
into
points.
2 categories: qualitative forecasting.
what
and
are the 2 points here?
quantitative Forecasting.
One is we call that
qualitative
lower control
techniques
limit, LCL.
Is a inclusion
and
of
the
so-called
other one
soft
is
information,
upper control limit,
which we use
UCL.
our past experience.
Now,
we use
if
the expert's opinion and our
the
hunch.
value of
Okay.
those X
So the
bar from
big
that
problem
specific sample falls
is
in
it's difficult
between
to
these 2
quantify.
points, which means in this
Okay.
basically
The
in this
other
highlighted
po-
area.
potential problem
call this
is
particular sample
sometimes
in
it
control.
is difficult to rely on
In other words,
hunches, expert opinions
the,
to predict what's going to happen in
we're,
the future.
we're saying that
Now there's
this
another way that is
sample
more
means stay close
rigorous.
enough to
We
specification.
that's what we will cover in this chapter.
If a
and it's,
sample mean X bar,
quantitative forecasting, and we use
falls outside of
hard
this
data we
2
collect
points, LCL and
to
UCL,
predict
we
future
say it is out of control.
in the business world.
In
The
other words, the X
qualitative
bar stays
inputs
too far away from the average.
can
It's
be the opinions
inconsistent
from
with
executive, from the
specification.
sales force, from the
Later
consumers,
on,
and
we
so
can
on.
turn this normal
So
distribution
now let's look
around.
at the
So we
quantitative
turn it at
forecasting
90
method.
degree.
The
turn it
first
from
method we will
horizontal to
introduce
vertical
is so-called
it will look like
naive
this.
And
let's look at an example
to learn this
show
method.
that in the run chart.
Now we know at
For now,
period
let me just say
one,
that if we turn it around, it still works the
the
same
actual
way.
demand is a 42.
Just don't get surprised when we something.
Now we know
from
the
horizontal
past demand,
vertical.
which is
Recall
the
that we
past
have a,
period
in
is
our
period
example, we have
1.
a s-
The
3
demand
samples,
was
sample 1, sample
42.
2, sample 3.
Now the future we would like to know
sample
is
mean
period 2 here at this
94.4,
moment,
96
and
94.8.
That's the
we
sample
use
made.
a
Okay.
very
Our
naive
three
method.
samples in our
That
example.
is, we
So we
assume
can
that
draw
what happened
three axes.
in the
For
past,
sample
which
one,
is 42, will continue
we
here.
can draw a
Okay,
axis
so our forecasted demand for period 2
right here.
is 42.
And we
Now,
mark 94.4
time
here.
moves on.
Sample 2, we
Uh,
mark 96
Period
here.
2
Sample
was
3,
the
we mark,
future, now becomes the
94.8
past.
here. Basically,
So,
this
our
vertical
forecasted
line
demand
is
for
the
period
axis.
2 based on the demand
remember,
from period
central
1
limit
is 42.
theorem, we know
Okay.
that the sample min x
And
bar
at this
follows
moment,
a normal distribution.
When time
So we
moves
can
on,
draw a normal
the period 2
distribution
becomes
above this
past,
axis.
and we learned
Another
the
normal
actual demand
distribution
of it. The actual
sample
demand
2
of period
above
2
the,
is 40.
axis for sample 2.
Okay,
Another normal distribution here.
so our future
And,
right now
this line
is period 3.
will be the upper control limit. This line will be the
the,
lower control limit.
Demand of period
Now
3
we
is
want-
something we want
what
to
we're
know.
doing
What are we
is
gonna
we
do?
need to make sure that all those red
We
dots
predict that our demand
are,
for future 3 is exactly
within
the
this
same as
UCL
the
and
demand for
LCL. We call
period
that
2,
in
which is a
control.
40.
If it is outside of this
Now let's
two
do one more.
lines, we call it out of
Suppose
control.
period 3 becomes
In order
the
to,
past as time moves on.
Understand
And
the
the period
situation
4
better. This
is the
another
future now.
example.
We
Now,
learned that
we have
the
UCL, we
demand
have
for
LCL, we
for
have
period
many
3
samples.
is 43. What we can
many
predict
samples.
is
These are
the
the
period
sample
4 we
mean
have
are the
43,
dots.
which is exactly
And,
same as period 3.
We draw
Now
those
here
dots,
comes a couple observations.
and we're trying to
Period,
find
in
if
our
the
naive method,
process
we only
is in control or not.
look back one
Now, if
period
the process is within
and
is in
use the
control,
demand from the
then
past
all the
period,
dots should be
the one that is
in
just
between
happened
UCL
as our
and
future
LCL. However,
demand.
we find
Now,
there is a dot right here
Let's say the
that is
demand for
above the
period 2 is
UCL
40.
line.
Has that
So
does that
we
has anything to do
conclude
with our
that this process is out of control.
predicted demand for
So now we
period 4?
understand
The answer is no.
about the mechanism of
What about period
statistical
1,
control
42?
theory,
Does it has
technique.
anything to do with our future,
you
which
probably
is 43
start to wonder
here?
how do we get the value
We
for
don't care. We only
UCL
look
and
back one period.
LCL?
So
Now,
another
here,
question you're probably gonna have
for
is
X bar for the sample
for
mean,
the
sample
forecasted
average. Here is
three,
the formula.
forecasted
UCL equals
demand
to,
here. For example, if we don't know the demand for
X
future
bar plus
period
A2
4 here,
times R bar.
and we don't know this.
LCL
Can we
equals to
use
X bar minus
forecasted
A2 times R bar.
demand from period 2
Let me
or from period 2 or period 3?
go through an example
Can we
and show
get some
you
information from
how
here?
to use this,
The answer is no.
this formula.
We don't care.
In our
We
previous
only look
example,
at
we
back
have 3
one
samples.
period and look at the actual demand, which is 43.
And in each sample, there are 5
Now,
units.
as time moves on, period 4 becomes the
So we
past,
take
and
the
period
average
5 is
sample
on the
mean,
horizon, and we
which
want to
is
know.
highlighted
We want to
in
know
this, blue.
the forecasted
And basically it's
demand
the
for period
sample
5.
average. We
So
also
here
call it
is
sample mean.
the exercise for you.
The other one we
please take a
calculate
moment
is the sample
and
range.
find out
Sample
the
range equals to maximum number
forecasted
in the
demand
sample minus
for
minimum
period
number
5
in that
using
sample. So the
naive
maximum here
time
is
series
95, minimum here is 93. So 95
Okay,
minus 93
I guess that's
equals
simple
2.
enough. And here is
For sample
a
2,
more complete
The
picture.
maximum is
of,
97. The
this
minimum
example.
is 95. 97 minus 95 equals to
Okay,
2.
so
For
the
sample 3,
predicted
The maximum
demand
is
for period 5 is
97,
40,
the minimum is
which
92.
is
So
based
the
on
range
the
is
actual
97
demand
minus
of period 4.
92 equals
Okay,
to 5.
we use naive method.
Uh, That's the range.
Now, after we try the
Then
naive
next we
method,
calculate the grand
you
average.
probably think
Grand
it is
average,
a little
average
too
basically
naive.
is the average.
Can we do any
of average,
better?
so we call that
For
grand
example,
average.
we following the same example,
For
but
the,
now the past
average of average
is
calculated
period
this
1
way. We take the average of the sample mean x bar
and
here. So we take the
period
average
2,
of
period
this
3,
mean
period
average.
4, period 5 are all
And
the past.
that
And
average gives us
we
a
want to
number
know
here,
period
which
6,
is the grand average,
which is the future.
that is 95.7.
We want to know the demand for period 6.
Range
And
here
there is
has an
a
average as
method
well.
that we probably
call
can do
it
a little
R
better.
bar. R
We
bar
got that at
basically is
moving
the
average
average
method.
range.
Simply put, the
And,
moving average
it
method
equals
is to
to
take
2
the
from here,
average of 3
2
past
from
the
here,
period
and
and
5
take an
from
average.
here, divide by
So
3
43
equals to 3.
plus 40 plus
So
40.
now we are ready. We have two numbers. One is
Now,
grand
as the time
average.
moves on, and
The other one is
period
average
6
range.
becomes the
So we have x
past,
bar, the value of
and
x bar, and the
period
value
7
of
becomes
R
the
bar.
future. We can
also
take
need
3 periods in the back, which is
number we
for
call that
period
A2
7, the 3 periods
from our
in the
from our
past
formula.
is 6, period 6,
So,
period 5,
in
period 4.
table
We take an average of
10.3
them,
in the textbook.
and we divide
we have a
40 plus
factor
41
for the we
plus
can find the
39
A2 value
divided by
for 3
3,
sigma.
it equals to 39.666.
Now,
And that is the 3 period
this
moving
one,
average.
the factor for
for
x
period
bar
7.
chart.
For the moving average method, we
in
don't
this
have
column.
to do
So this is
3
what
periods.
we're
We can
using
do a
right
2
now.
period. So let's see the example.
And we
The
first
2 periods
look
in
at
the back
number
is the
of
period 1
observations
and the period 2.
in subgroup.
And we know their
in
actual
each
demand is
sample,
42,
basically.
40.
Subgroup here
And
means
for
sample.
period 3, which is
Now,
the future
we
now
have
in this case,
how many units in our
we
sample?
simply take
5.
the average of the last 2 periods.
So we know
and
that n equals
The
to
average
5.
of these 2 periods is 40 plus 42
Okay.
divided by 2 equals
Now
to
we
41.
look at this column.
And this
Here,
is
first
a
column, we look
moving
for
average method
where
too.
the
So
n equals to
we
5.
can do however
right
many
So we look for the
periods.
number.
Look back. For
in the
example, we can look back
corresponding
3 periods. We can look back 2 periods. We can look back 4 periods.
column for
All depends
A2,
on how we which
which is
method
here,
we think is the best
then
for us.
our value for A2 is 0.058.
Suppose period
So
3
what we
passed.
found from
and
this
now
table
period
is
4
A2
becomes
equals
the
to
future.
0.58.
We want to know the
Now let me
demand
put
for
this
period 4.
X bar
And
control
we
chart
use
for
a
UCL and LCL
2
here.
period
Again, it is
moving
copied
average.
from the previous
What we do is
slide.
we
It's
take the
exactly same
average
thing. What we
of
need is to plug in
period
3
2 and
numbers
period
here.
3.
X
So
bar
this is
bar,
an exercise for
R
you. Would
bar,
you
and
please
A2. We
calculate
found this
the 2
3
period
numbers.
average
And then we plug in
and
the 3
make a
numbers
prediction
to
about
this
the period 4.
formula. We get UCL equals to X
And we
bar
take
bar,
the
which
average
is
of 2 periods,
95.7,
which is period 2 and period 3, which is 40
plus
plus 43
A2,
divided by 2 equals to
which is
41.5.
0.58,
Now this forecast
times R bar,
is based on
which is
the
the
average
3.
of these 2 only.
So this
it
one
has
equals to
nothing to do with this one. It has
96.81.
nothing to do with this one. It is only the average of period 2 and period
the
3
LCL.
actual demand.
We
Now,
found the value for UCL and LCL now. So we know UCL equals to 96.81, LCL equals to 93.33. So we draw 2 lines here. Okay, sample 1, for sample 1, the value is 94.4. So it is in between 96.81 and 90.